So I briefly mentioned that at different times in the year, the sun appears at different um, altitudes in the sky. And in different seasons, the sun appears at different altitudes. So we can talk about it here by thinking about our celestial sphere. Okay, so of course, during our orbit around the sun is stationary in the center, and it's the Earth that's executing this orbit here, right? But if we think about our celestial sphere, here we are standing on the surface of the Earth and we're looking up at the sky. And then we're tracking the position of the sun as we're making this orbit around it in our sky. Okay, so here's the celestial sphere. We've got the celestial equator right here that's taking our Earth's equator and stamping it up on the sky. And here we have the ecliptic. Remember, the ecliptic is the path that the sun takes in the sky, which is reflective of our orbit around the sun. So in this picture here, we've got our celestial pole right directly above us at 90 degrees here. But since our Earth is tilted, that means that the sun is going to appear to take a path that's tilted in the sky with respect to the celestial equator. So here we've got our celestial equator, and here's the path, the ecliptic, that our sun takes in the sky during the course of the year. So there are four pretty special points that we're going to talk about, okay? And so the first one, we'll just start here with the vernal equinox. The vernal equinox, vernal is Latin for spring. Vernal equinox is the beginning of spring. Equinox means equal amounts of time. So on the vernal equinox, there's equal amounts of daylight and equal amounts of darkness. And this is around March 20th, 21st, 22nd. And here we have, at the vernal equinox, the sun is directly crossing the celestial equator. It's crossing the celestial equator and it's heading north of the celestial equator, okay? And then when we reach the summer solstice on June 21st, or June 20th, 21st, 22nd, depending on the year, we have the summer solstice. That's the day when we call the beginning of summer. And on that day, we have the greatest amount of daylight, okay, in the Northern Hemisphere. And on this day, the sun is the highest it can go north of the celestial equator. We'll also see it with its highest altitude in the sky on that day. And then back here at the autumnal equinox, or the fall equinox, the beginning of fall, we have the sun again crossing the celestial equator. It's crossing the celestial equator and it's heading down into the southern part of our celestial sphere. And then here on the winter solstice, around mid-December, we have the sun at its lowest point in our horizon in the Northern Hemisphere. And that's when we call beginning of winter. And that winter solstice is also the day when we have the smallest amount of sunlight and the greatest amount of darkness. And so again, let's define some of these points. The equinox, when I was talking about the autumnal and vernal equinox, the equinox is the date when the night and day are exactly 12 hours each. And these happen again around March 21st for the spring equinox and September 21st on the fall equinox or the autumnal equinox. Okay, so the summer solstice is the date with the longest amount of sunlight, and this happens around June 21st for the Northern Hemisphere. And then the winter solstice is the date with the shortest amount of sunlight, and this happens around December 21st in the Northern Hemisphere. And so the path that the sun follows each day can be pretty different depending on your latitude. So let's take a look at what that looks like when thinking about 3 different latitudes on the surface of the globe. So let's go to the North Pole. If we go to the North Pole, zenith is the point directly above us. We're standing on the pole of our planet. Okay, and so the sun will appear highest in the sky on the summer solstice, so June 21st. And then as you progress from the solstice of summer down to the beginning of fall, the altitude of the sun in the sky is going to decrease towards the horizon. And then once you hit the autumnal equinox, all the way through the winter solstice, and then all the way back up to the vernal equinox, the sun will always be below the horizon. It will only start to peak up above the horizon at the North Pole when you get past the beginning of spring, the vernal equinox. And after that point, the sun will continue to rise in altitude in the sky. So half of the year, it's light all the time in the northern, at the North Pole, and half the year it's dark all the time at the North Pole. There's only one place on the globe where the sun will ever go directly overhead through zenith, and that place is at the equator, and it will only do that twice a year on the autumnal and vernal equinoxes. Will the sun's path on those equinoxes go directly through zenith? Okay, and then as you deviate from the equinoxes and you're closer in time to summer, then the sun will appear to deviate from directly overhead and will be more northerly facing. And then as we deviate away from the equinoxes more toward winter time, then the sun will appear to be directed more toward the southern cardinal point in your sky. And so the sun will fluctuate back and forth through zenith for you if you were at the equator during the course of the year. But here's another way we can talk about the sun's position in the sky during the course of the year. And that is with something called an analemma calendar. An analemma is a diagram that shows the position of the sun in the sky as seen from a fixed location on the Earth at the same time of day over the course of a year. So here's an example of an analemma for a particular location. We've got the altitude, that's the sun's angle above the horizon. And here we have the azimuth, the sun's position, with respect to north, south, east, west. And remember, 180 degrees is facing directly south for azimuth. And so here we have the little red dots are the position of the sun, let's say at noon, every day during the course of a year. And here we are at, let's go with the summer solstice. And on the summer solstice here, we see that the sun has its highest altitude in the sky. And then as we progress through August and September toward the autumnal equinox, the sun's decreasing in its altitude in the sky. And then as we come through towards winter time, towards the winter solstice, and exactly on the day of the winter solstice, the beginning of winter, the sun will appear to have its lowest altitude in the sky. And then as we move away from winter solstice toward springtime, we see that the altitude of the sun in the sky increases again, and it continues to increase until we get all the way back up here to our northern hemisphere summer solstice. And so we trace out essentially this figure 8 pattern in the sky. That's the analemma, this figure 8 pattern that we trace in the sky by tracing the sun's azimuth and altitude. And so you can use this as a calendar to figure out where we are during the course of the year just by tracking the sun's position at the same time every day. And again, this figure 8 pattern is different, this analemma pattern is different for every location on the globe. How stretched out it is, how fat it is, and how inclined that figure 8 pattern is with respect to 180 degrees azimuth all has to do with small changes in the sun's declination and right ascension during the course of the year, the Earth's tilt, and the fact that our Earth doesn't orbit the sun in a perfect circle.